we are going to be dealing with counters. All right. So, first, getting a PLC into the code. All right. Some of you guys are having some issues with that. You know, at getting your code, your PLC added without having all your code into it. All right. Remember, there are two ways to get a PLC into a new program. Option one is the manual way, which is doing the add new device here and going down and selecting your specific PLC. Remember, we are using the 1214C AC/DC relay with the identifier 1BG40, I believe it is. It's either 1BG40 or 1GB40. I forget what it is off the top of my head. But it's that one. So you can do that option, or if you click on the name of your program, you can then do online and upload device as a new station. Now, this will bring in all of the information that is stored on your PLC. So if your PLC has your last program on it, because, well, you've just finished that one, you're creating a new program to start working on the next one, it's going to bring all that code into this as well. So you might as well have just done a save as at that point. All right. So your better option is to reset your PLC before you do this option. All right. Which I do highly suggest that you guys do between different assignments, so that way you make sure you don't have funky things getting brought along with you. But, you know, you're welcome to try it. So anyway, so we need to go ahead and just create some tags. All right, and I'm just going to call it button, just to give me some button inputs to play with. Come on. There we go. And then we'll just go ahead with output. Remember to change this to outputs. And we can go ahead and give us a few of those as well. All right, so if we go to our program. Now, just like with timers, we're going to use the little question mark box. Now, a friendly reminder, if you don't want to use the question mark box, you can use the instructions in the top right-hand corner, which will then allow you to have a whole folder dedicated to counters, which there are 3 of them. CTU, CTD, and CTUD. So CTU is what type of counter? CTD is? And CTUD is both, right? All right, so we have a count up, a count down, and a both. All right. So let's just go ahead and throw a button on here for good measure. And then we're going to go, I'm going to use the mystery box, and we're just going to go with a CTU for now. All right, remember, it's going to create the data block with everything that you need as part of it. All right, and remember, you can always come into the system blocks on the left and actually look up your data blocks. I know it's a little kind of like grayed out, almost like it's hidden, but here you can come in. And if you notice, we do actually have all of the quantifiers for it. We have the CU and the CD, even though we just created a count up counter. It actually does have CD as part of it. It also has the QD as part of it, which is the count down related things. When you create a counter, it creates all of them no matter what type of counter you're using, which is nice because if you want to change it later, you don't have to go through the process of trying to figure out, like, why isn't it working? It's all those variables are already there for you. So it's really nice in that aspect. Now, on our counter, a little bit big. All right, so R is what? Reset. All right, just like a timer. All right, and again, we can, if you need to put a whole bunch of things on here, you can do a new branch, and you can do your craziness, and then drag that to the R for reset, so you can have your 3 items. Yeah, that'll have to be true on your reset. Some of you guys, to pass my crazy reset category, you did another bit, so you had, you know, those 3 items down here with a memory bit, and then you just put that memory bit in there. That also works perfectly fine. All right. It all comes down to how you like it. What is PV? Preset value. Do we have a unit associated with this one? Like timers, we had seconds, right? Or milliseconds, or hours, or minutes. Do we have that with this one? No, right? We don't have any units. It's a count. It's just a quantity. All right. So if we actually would hover over this, I can leave my mouse there. It says int, word or implicit data type conversion possible. So an int, INT, is an integer. All right. So any integer would work. So if we had a data type, we had a tag for an integer, we could just type that tag in here, and then we wouldn't have to come set it specifically at this counter, which is kind of nice. And next semester when we're playing with HMIs, since I don't think we're going to get there this semester, you're gonna have to do that. So that way the HMI can actually access the preset value, and we could actually change it from the HMI. All right. It's kind of nice to have tags for that, so you don't have to go find all of your counters when you want to update numbers. All right. And let's again kind of go back to like industry. You know, it's not something that you want to have to go through your entire program to go change your value. It's nice to be able to do all your values from one location. So normally you'd probably put a tag here for purposes of our class, since we haven't learned about integer data types or anything like that. We're just going to go ahead and type a number in here. So I'm going to just go with a nice round 10. We have CV, which is what? If PV is our preset value, CV is our what? Counted value. All right, how high have we counted? All right, and again, there is no red question marks there, which means we don't have to put anything in that location. Again, if you wanted to save this as a different tag, like a tag specific to be shown on your HMI or something like that, this is where you would put that tag name, so it automatically would keep that tag updated every time the counter changed. And we'll talk more about that later when we're dealing with HMIs next semester. And for my purposes here, let's just go ahead and make this a nice little button 2. And I'm going to do what I don't like you guys to do, but just for simplicity, we're just going to throw it there. All right, so nice, simple little program written up here. 2. Not happy with me. Trying to find our PLC. All right, so any of you guys have any major questions about counters? Do you think it would have been easier to do counters before timers? Now that you guys have read both chapters. Do you think so? Because counters are simpler, or because... Yeah. Okay. I said, I think overall I'm going to next semester, I'm going to flip-flop them, but the book did timers first, so I was like, okay, let's do timers first. And I'm kind of think I overall regretted that, but that's okay. Really? You're not going to work now, huh? There we go. All right, so. So we actually already have our output on, which is kind of interesting. Let's see what's going on in our code. Yeah, better with this off. We're already at 17 somehow. That's kind of interesting. All right, so anyway, button 2, so let me go ahead and reset that. There we go. So every time I flip button 1, let's see if I can make this ever so slightly bigger instead of like stupidly big. There we go. Again, right at the top of the counter, you can see it's happening. All right. And notice it only detects that one transition. All right. Right now that switch is still on. The line is still green. It's not constantly counting. All right. It's not like the timers that just keep counting and counting and counting, you know, as long as the input's true. Counters, on the other hand, they count one positive, negative to positive transition. All right. So every time that CU gets a positive, that transition, that's when it counts. All right. So every time we flip it on and off. All right. I did show you this with one shot. So if we did a negative transition or a negative transition, it still sends that positive pulse, but it sends that positive pulse when that switch gets turned off. So it's still sending a positive pulse. The counter still counts it, but it's kind of a backwards way of doing things in the long run. All right, so count up counters. Overall, I think they're pretty simple. Once we get to that magical 10 number that we put in that PV, then our output turns on. So Q turns true there. All right. Let's go ahead and make this a CTUD instead of just a CTU. Not what I wanted to click on. Come on. Okay, so now notice we have CU, CD, R, LD, and PV. All right. What does the LD do? Okay, but what does loading do?
Pretty much puts the whatever amount of time is on PV when it resets. I don't know if that's correctly or not.
You're close. Not time, but... All right, so as Dan was saying, all right, load, what it does is it takes the value that is in PV and puts it into the CV point. All right, so reset takes the value and sets it back to 0. LD takes it and sets it to the max value. All right, so a little bit of give and take going on there. So let's go ahead and again, let's see what's going on here. All right, so we are at 10 right now. So QU is true. Is QD true? No, QD is not true at this point. All right. Now, as soon as we go down 1, notice QU goes false. Is QD true? No. All right. At what point is QD true? Well, we're below PV. We're at 9 right now.
Oh, we are.
Sorry. 0, that is true. Anything else? What?
Anything else is happy.
Okay. So, the key here is 0. However, it's less than or equal to 0. So if we go ahead and reset this using, what is that, 2? We're now at 0. If we count down, so... Oh, and of course, it's not going to show us QD is true because there's nothing on it to output. Let me go ahead and just quick re-download this. There you go. Now we can see QD is true. All right. So notice we are at -1 right now. Now we're at 0. It's still true. As soon as we're above 0, QD goes false. All right. So QD is less than or equal to 0. QU is greater than or equal to what? PV. All right. So if CV is greater than or equal to PV, then QU is true. QD is true if it's less than or equal to 0. All right. Now, here's the one fun question that I have. How do you go about keeping a counter from counting higher than its preset value or less than 0? Using Boolean logic. All right, there is some math operations we could put in here that says if this is less than this, but I don't want you guys using that. That's too complicated. There's a much simpler way.
Could you use the output to reset it?
I don't want to reset it, I just want to stop it from counting higher. But yes, we can use the output. All right, so if you want to keep it from output counting higher, now why would you want to do that? I'm not actually sure.
Is it a QU break contact?
Yes, it would be a QU break contact for the count up. All right, so we can do a break here, and we could say our counter QU. And then for this one, it would be a break contact counter QD. I don't know if this is going to work, but yeah, of course, I got rid of button 1. That's kind of what I expected, but you know, still. All right, so if we do something like that, then we won't be able to count higher than the preset value, because as soon as we hit that preset value, that break becomes an open, which means we can't count higher. So even if we're flipping that switch more, it won't keep counting up and up and up. All right. Now, again, why would you really want to make it stop counting? I don't have a good answer for that, because if you're still counting, you know, you're still going up. You know, there's more bottles passing that sensor or whatever the case is. All right. So right now we're at 1, so now we're at 0. Notice I can flip this all I want. We're not going below 0. Let me just cheat and get up to 10. So now we're at 9. I can count up, but I can't keep counting, no matter how many times I flip this thing. All right. So nice little trick there if you absolutely need it to stop at the counted value if you don't want it to keep going. But again, normally there's probably a reason why it's going to keep going. It means there's more bottles flowing past a certain point, or something along those lines. So you probably want to do something else instead of just stopping it from counting higher. Say you're loading a 24 pack of something, right? You're putting bottles into the case. Oh, we hit 24. All right, crap, now we hit 25. Where's the machine going to put that 25th bottle? Well, I don't know. All right. It should have marked it that 24 have gone past the sensor and stopped it, and allowed something, push that bottle to a different packaging machine or something along those lines. But it didn't. It let it slip through. So I don't know why you'd want to be able to count higher. So a little bit of give and take going on there. Now, how fast do you think this counter can count?
Fast as the input can change.
Okay. How fast does it check its inputs? What? Okay, full scan. How long does a full scan take, do you think, right now? I think it takes a minute, a second, 10 milliseconds? What?
5 milliseconds.
Exactly, probably milliseconds. So we can actually go through that. We can go look. We can look at our online and diagnostics. You guys remember we did talk about this. And over here on the right, or we can come to cycle time, that'll be even better. So you can see here our cycle time set, our minimum was 0, our max monitoring time is 150. All right, and our cycle time measured, our shortest is 1 and our longest is 2. Currently we're running at 1. All right, now will the counter count? So we're counting at 1 millisecond, or we're looping at 1 millisecond. All right. Will it count 1,000 times per second then? How many people think yes? Raise your hand. Nobody. How many people think no? Raise your hand. Still nobody. This got a 50-50 chance here, people. Let's go ahead and roll some dice here. All right. So if you think it's going to count 1,000 times because the program is looping 1,000 times per second, raise your hand. All right, I got 2 people. All right. If you don't think it's going to count 1,000 times, raise your hand. Why isn't it going to count 1,000 times?
You have to trip your input count.
Well, okay, but if the input is, if you're saying there's 1,000 bottles going past a certain point in a second, is it going to count all 1,000?
Your counter's limited.
What? Oh yeah, okay, my counter is limited right now. That is a good point. All right. Not my point I'm trying to make, but that is a good point. All right. If I just have a sensor, right? I got a bottling line, right? And we're just swirling bottles past this thing. All right. And I have a sensor counting every bottle that goes through. All right. How many bottles, if I'm looping at 1 millisecond loops, how many bottles is the max that this counter could count per second? All right. What?
1,000.
Nope. Remember, we need a transition, and it needs to be able to grab that transition. So it needs to go from a high to a low. So if there's 1,000 bottles going past that sensor in a second, basically that sensor is staying lit as far as the program's controlled, right? Because it misses that that drop because it's not updating that tag table fast enough. All right.
Get half.
So we'd only get 500 per second. Now, that's still a lot of freaking bottles. 500 bottles going past something per second. All right. But my point here is this is a counter that is really overall meant for slow changes, right? It's not truly meant for absolutely rockin' high speed. All right. Now, there are counters built into this PLC, all right, but not most, that are called high-speed counters. And their whole goal, their whole job is to count things at high speeds, all right? So obviously, if your program lasts more than a millisecond, if your program is 1 millisecond, we could, in theory, count 500. And that's assuming everything is a constant pace, all right? Now, if we all of a sudden are at 2 milliseconds, we only can count 250 bottles per second. All right, so you can see how our program going 1 millisecond bigger all of a sudden plummets how many bottles we can count. All right, now how many programs are actually running at 1 millisecond? Very few, right? A lot of these industrial programs, they might have 1,000 lines of code. All right, and even if you say that's running at 5 milliseconds or let's just go a little crazy and say 10 milliseconds, right? We can run 100 lines per millisecond, all right? So 1,000 lines of code taking 10 milliseconds. That means we're running at 100 times per second, which is still plenty fast probably for most things. But again, it means only 50 bottles can get counted through a sensor as long as they're consistently moving, which that one should be still plausible, but we could start pushing the limits here. All right, so you can get what's called a high-speed counter. And as I said, these actually, if you go into device configuration, let me bring this window up at the bottom and go to properties. There is actually a high-speed counter that is built into it, and we actually have 6 of them as part of this, part of these PLCs, which is very nice in the long run. So we can enable it. We can give it a purpose. So let me go ahead and enable it so I actually have my options. Helps if I go offline, I guess. Cancel, wrong button. All right, so we can enable it. We can go check things. So we can have count, we have period, we have frequency, we have motion control. All right. Then you get into single phase versus 2-phase versus an A/B counter. All right, so there's options there. And what these high-speed counters are truly meant for is for encoders. All right, now what is the point of an encoder?
Encoder tells you the position of a motor.
Something, all right? Right. Most often a motor, all right? So CNC machines, all right? Ideally, you're going to have encoders on them. So the computer is going to tell the CNC machine to move from point A to point B. All right. Ideally, you have that encoder there, which actually counts how far it actually has moved. All right. Now, oftentimes these encoders are at like 500,000 clicks per revolution of that motor. And if that motor is moving at 100 RPM, so 100 times per minute, let's go with 60 RPM. All right. So it's doing one full revolution is per second. That's 1,000 clicks that thing has to count per second. All right, and by doing an A/B encoder, where it can actually determine which direction it's going by the pattern of A/B bits, which one have it's basically no A/B counters basically go no signal, A signal, B signal, and then A goes off, then B goes off. So you can. There's actually a specific pattern to it. I think that's how they work. There is a pattern. I guarantee that. I think it's no A signal on, B signal on, A signal off, B signal off. So there's 4 distinct stages. So no signal, just A and B, just B, no signal. So there's 4 distinct phases. So you can always figure out which phase you're in, and then you can always see whether it went 1 click right or 1 click left. All right. So it is actually able to then determine which direction the motor is spinning, so that it knows whether to count up or to count down based on that. All right. And in fact, the robotic arms, which are up top over there, those have encoders in them. So we actually, if we want to use those correctly, we actually have to enable these high-speed counters to use those encoders because they go so damn quick, the PLC just can't, the program itself can't keep up with it. So basically, the high-speed counter is its own little dedicated device with what's called interrupts in it. That basically, anytime that click changes, it stops what it's doing, goes and runs the interrupt code, which basically says count up or count down, and it goes back to what it was doing. All right. And then every loop of code, it just goes to that high-speed counter cache, and it goes, hey, what's the counted value? And it goes, oh, thanks, we're at 600 now, or oh, we're at 800 now, or whatever it is. So the main PLC program doesn't actually have to keep track of that. Traditionally, especially in larger PLCs, the high-speed counters are going to be their own module. So you'll just buy this extra, you'll be like, oh, I need to do a high-speed counting. You'll buy one of these modules, you'll slap it on your modular system, and you're good to go. With this one, said we overall actually do have 6 of them built in. Now, one thing we do have to do if you're going to be using a high-speed counter, which again, we're not really going to be actually playing with them this semester, but I do like to talk about them. All right, is you have to come in here to this input filter. All right, because right now it says for me to consider something true, it has to be 6.4 milliseconds. All right, so the instant you flip that switch on, your PLC goes, no, that's not true yet. And after being true for 6.4 milliseconds, that's when your PLC actually goes, all right, That is an actual signal that I'm supposed to listen to. All right. So that way it's not like something induced on that power line that it's triggering it to go, yep, yeah, there's something there. And you just see like a light flickering and you're like, what the hell's going on? Well, maybe you have your AC line too close to the DC line, or there's a motor too close to your button or whatever, that every time you turn that motor on, there's a spike of power that gets transmitted to the wiring. Well, this will, in theory, ignore that spike of power and not qualify it as someone pressed the start button, so the whole conveyor starts moving. All right. So if you want to use these as high-speed counters, ideally you want this to be just slightly less than whatever your counter expected signal is. All right. So again, that way we have the most error rejection possible here. But you can see here we can go all the way from 1 microsecond all the way up to 20 milliseconds. So we can go from 0.02 seconds for it to be true down to, what did I say? 0.1 microsecond? Holy crap. Right? Millimicro. So that's 0.06 or 0.10000001. So basically, as soon as you flip that, it's true. All right, so you do have to play with those types of things to make sure those high-speed counters are working correctly with the Siemens PLC that we're currently using, at least. All right. Again, with those dedicated high-speed modules, there's probably some other configurations that you might have to tweak, but just something to take into account. So, counters. Overall, any big questions? Oh, actually, one thing I do want to point out. Notice we have QU here. All right. If I just pick this back to a CU, it just becomes Q. All right. So it's not, well, we've reached the top limit. And where it really gets confusing is when we take it to a CD, it's still just Q. All right. Yeah, I think they would have made it just QU and QD on a count up or count down respectively. And then when it was both, they would just stick with the same language. But they did not. All right. So that is something that you do have to be slightly aware of, but overall, again, it's not really a huge issue because the program, when you're like, coming in here and you're like, okay, IEC, and you're like, okay, let me count that. Actually, it does. It gives you QU and QD in here. So even though up here off the counter, it's just Q, you still have actually the option for QU as well as QD. You also notice on the countdown, instead of reset, it is load. All right. So, questions, comments, concerns, issues, and/or statements? Yes.
Would you use these to, like for data collection? Would you suggest that, or?
What do you mean by data collection?
Like, say you just want to know how many bottles we ran today on our plant. Would you use a counter like this to just rack up 100,000 count or whatever? Or?
Again, as long as your inputs aren't changing too fast, yeah, just a normal counter will be fine. Maybe a better option instead of bottles, you'd say pallets.
Okay.
Because, you could say, okay, we've got, 300 bottles on a pallet. We could just say, okay, one pallet is 300, and then somewhere you could have a little math operation that says pallets equals, number times 300, and then on your HMI you would just say number of bottles or, completely packed or something, you'd go 300.
And like so what you were saying, that's where you would use your count value.
Yeah.
Going to your HMI.
Exactly.
If you're counting to display each bottle.
Yeah. So you guys will be doing a parking garage exercise where you're going to be counting cars in and out based on some sensors and things like that, and if there's too many cars in, you're going to close a gate. You're going to lower a gate so no one can come in. Once there's, once one car leaves, you'd open the gate back up. Those types of things. All right. Now, I don't know if you guys had the issues with it or not, but if we go ahead to PLC Fiddle, for those who did try to do this. All right, we do have counters in here, so you can go ahead and just type in a counter, whatever it is, create your one. If we click the drop down again, you'll see your EN, so it's powered, or the to count is enabled. Q is done counting. We have accumulated, which is how many we've counted. We have our preset value, which is what we're counting to. And again, if we come in here, we have a count up, and we also do have a count down option. Let me go ahead and add another rung. I don't know how this will work, but we'll give it a shot. Let's just go with 5.
if you wanted to do a count up and down, you would just come off the same run.
So in theory, that's what I'm trying to do right now, is a count up, down. I don't know how this will work, but let's find out. But you notice on this one, you see how it's constantly counting? Alan Bradley has this same issue too, actually. If you try to do a count up, down, they don't exist in Alan Bradley world. Like, you don't have the option to do both, which kind of annoys me. But if you notice, this one's constantly counting. Alan Bradley does it a whole hell of a lot quicker, again, because the program's running a lot faster. So this is kind of showing you it's a loop time, basically. All right. But because we have the count up and count down, we have two separate blocks referencing the same counter. It's just bad news in the long run. So what you would need to do in this case is you would actually have to put that that one shot in here. One shot one, one shot two. So if we go ahead and do a one shot in there, now it will only count. Let me just go ahead and make this back to 0. Now it'll only count one button press. All right. So you have to do that same type of thing in Alan Bradley world. Because Siemens has a dedicated count up, count down, it's all built into one nice little smart block. We don't have to do that type of stupid nonsense. All right. But in PLC Fiddle, if you want to do a count up, down and not have it just constantly count, 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 count. And with Alan Bradley, same thing. You have to put a little one shot in there. But it is possible to have the two different data blocks, or two different instructions, a count up and a count down, both referencing the same counter. All right. So it's possible. It's just a little bit of a fun little game that you have to play to make it work how you expect it to work, not just right off the bat work for you. So overall, I think counters are pretty simple. As I asked at the beginning of class, I think next semester I'm going to do counters first because I think they are a simpler thing to wrap your head around. And once you learn how to use a counter blocks, using a timer block I think is going to be a little bit simpler. However, you guys already use timer blocks, so counter blocks should be an absolute cinch. All right. The only difference between a timer and a counter is a timer keeps counting when the button is held. A counter only counts one state change. All right, and then it stops. So kind of nice in that aspect. All right, questions, comments, issues? Not as of this point in time, at least. All righty then, so that will be the end of this wonderful little recording.